Okay, in this video I'm going to try and explain the chain rule and when you would use that and how you would use it. It's a little bit complicated, so you're going to have to watch this video maybe a few times until you get it fully. So I'm going to explain by doing an example. So we want to differentiate x squared plus 5x all to the power of 4. Now we haven't seen anything like that before, because usually what we would be asked to differentiate, or what you have been asked to differentiate so far in these videos, is something like x cubed or x squared or 3x squared, something like that. This time we've got a sum, we've got something in brackets, x squared plus 5x, two things, and then that's all raised to the power of 4. So it kind of looks like this rule over here. We have all our rules for differentiation over on the right hand side, and it kind of looks like this rule here, where we've got x raised to the power of n. We got something to the power of something. The only problem is that we got a sum here. We got x squared plus 5x, so we got two things added together, then raised to the power of 4. So what we have, in fact, is two functions combined together. The first function, well, first of all, before we do the sum, and I'll explain what I mean by two functions now in a minute. Before we do the sum, I'm going to start off by writing f of x is equal to x squared plus 5x all to the power of 4. Now we want to find f dash of x. That's what it means to differentiate. Okay, we've got two functions here. The first function is the bit inside the brackets, and the second function is that function raised to the power of 4. So I'm going to write that down. The first function is the bit inside the brackets, so I'm going to give that function a name. I'm going to call it h of x, and I'm going to say that h of x is equal to the bit inside the brackets, so x squared plus 5x. The second function is all of that raised to the power of 4. So I'm going to give that a name, and I'm going to say g of x is equal to all of that raised to the power of 4. So it's h of x raised to the power of 4. So h of x all to the power of 4, because h of x is this bit in here. And okay, so now I can differentiate h of x. So, and when I do differentiate h of x, so I get h dash of x. Well, it's easy to differentiate because it's just the sum. Differentiate x squared and I get 2x, just using these rules over here, and differentiate 5x and I'll get 5. I can differentiate g of x and I'll get g dash x. And when I differentiate that, here I've just got something raised to the power of 4, h of x raised to the power of 4. So I can use this rule here, because this rule just says if I've got something raised to the power of n, I differentiate that and I get n times x to the power of n minus 1. Here I've got something raised to the power of 4. I've just got one thing. H of x is just one thing to the power of 4. So when I differentiate that, I get 4 times, just using this rule here, so 4 times h of x to the power of 4 minus 1. I can tidy that up. I get 4 times h of x to the power of 3. But h of x is this part over here, so now I can fill it in. So I get 4 times, instead of writing h of x, now I can write x squared plus 5x all to the power of 3. Now in order to find f dash of x, which is what we really want to find, remember we started off with f of x is equal to x squared plus 5x all to the power of 4. So we want to differentiate that. What I did is I split this up into two functions. The first function is the bit that's inside the brackets, x squared plus 5x. So I said h of x is that, and I was able to find h dash of x. I said the second function, which I call g of x, is all of that raised to the power of 4. So it's h of x raised to the power of 4, and I was able to differentiate that to get 4 times h of x cubed. So now, in order to find f dash x, which is what I really want, all I have to do is to multiply h dash of x by g dash of x. So f dash x is equal to h dash x. I know I'm saying it's hard to say h dash x and g dash x all the time, multiplied by g dash x, which is, well, h dash x is 2x plus 5, so it's just 2x plus 5 multiplied by this g dash x, so 4 times x squared plus 5x all to the power of 3. Now I can tidy that up a little bit, because if you look here, I'm just multiplying a few different things. I'm multiplying this bracket by 4 by this, so it doesn't matter the order that you multiply. So I could tidy it up by multiplying 2x by 4 and 5 by 4 and then multiplying by that. So let's see, that would give 2x by 4 gives 8x, 5 by 4 gives 20, so 8x plus 20 times, and then this all cubed, x squared plus 5x cubed. And we can leave it like that. So that's the chain rule when we've got two functions mixed up together. So let's have a look at another example of that. Okay, so we're asked to differentiate x plus 1 all to the power of 5. Okay, so it's very similar to the previous question. So I'm going to start off, I'm going to write, there you go, you can see it now. So I have to differentiate x plus 1 all to the power of 5, which is very like the previous function. So I'm going to start off by writing f of x is equal to x plus 1 all to the power of 5. Now if you look at this, we can't just use these rules here, these ones, because we've got a sum, we've got something in brackets here, something plus something all to the power of 5, whereas these rules just allow us to differentiate when we've got one thing to the power of something. So we can't use that straight away. But I can split this into two functions. The first function is the bit inside the brackets, and the second function would be all of that to the power of 5. So let's write down h of x is the bit inside the brackets, x plus 1, and let's call it g of x is equal to all of that raised to the power of 5. So it's going to be h of x raised to the power of 5. Now I can differentiate each one of them. So here I get h dash x. Differentiate x, this is just a sum, it's easy to differentiate. I can use the rules of differentiation. So I can use these rules, the x to the power of n rule. So differentiate x and I get 1. And differentiate a constant, and what do we get? We get 0. Here, differentiate a constant and we get 0. So to differentiate x plus 1, we just get 1. I can also differentiate g dash x. So I can use the x to the power of n rule to get 5 times h of x all to the power of 5 minus 1, which is 5 times h of x to the power of 4. And I can replace h of x with x plus 1 now. So I have 5 times x plus 1 all to the power of 4. And now, if you remember from the previous page, f dash of x, remember we started off with f of x is equal to this. We want to find f dash x. We split it into two functions, differentiated each function, and now to find f dash of x, which is what we really want, we just multiply h dash x by g dash x, which in this case will be 1. So that's nice because it's just 1 times this. So 1 times 5 times x plus 1 to the power of 4. 1 times anything is just the other thing, so that's just 5 times x plus 1 all to the power of 4. Okay, so that's the chain rule. I'm going to do that question again, because if you remember, there's two notations that we use when we differentiate. So I'm going to do this question again, and I'm going to use the dy over dx notation. So, and I'm going to do it over here, and it's exactly the same. We'll end up with the same answer, but it's just using a different notation. And it's important to be able to do it both ways. So we have to differentiate x plus 1 to the power of 5. So I'm going to start off this time by writing y is equal to x plus 1 to the power of 5. Okay, so now if you remember, we've got a function inside a function. So I'm going to split that up, and I'm going to let's say if I just write h is equal to, so because I'm using the different notation, I'm not going to write h of x, I'm just going to write h is equal to, and I'm going to say the x plus 1 bit. So pretty much the same as over here. So if h is equal to x plus 1, that means that y is equal to, well, y is equal to x plus 1 all to the power of 5, but x plus 1 I've said is equal to h. So now that means that y is equal to h, because this part is h. So y is equal to h to the power of 5. Over here, I've got a h and an x, so I can differentiate this. I can find dh over dx. So because I've got a h and an x, when I differentiate with respect to x, I get dh over dx. So differentiate x plus 1, just using the normal rules of differentiation, I get 1. So it's exactly the same, except it's just a different notation. Here, I've got a y and a h, so when I differentiate here, I'll get dy over dh, and that will equal 5h to the power of 4, which is exactly what I got over here. So here, I had 5 times h of x to the power of 4, but because I'm not using the h of x notation over here, I just get 5h to the power of 4. Now, go back to the start of the question. We have y is equal to this. I want to differentiate, so really what the question is asking me to do is to find dy over dx. So in order to find dy over dx, over here, f dash of x was equal to this times this. So over here, dy over dx will just equal this times this. So dy over dx equals, and you'll see why now in a minute, and maybe it'll make a little bit more sense to you. So dh over dx times dy over dh. If you look at that, we want to find dy over dx. It's this, I'm saying it's this multiplied by this. If I multiply that by that, the dh's are going to cancel because I'm multiplying by dh, but then I'm dividing by dh. So the dh's will cancel and I will be just left with dy over dx, which is what I want. So dy over dx is equal to dh over dx, which is 1, multiplied by dy over dh, which is 5h to the power of 4. 5h to the power of 4. So here's our answer. I'll tidy that up by replacing h with what it is. So that's equal to 1 times 5 by, well, h is x plus 1. So x plus 1 all to the power of 4. And 1 times anything, remember, is the other thing. So I just get 5 times x plus 1 all to the power of 4, which is exactly what I got over on the other side. So there's two different notations, and it's important to get used to using both. And in the next video, when I'm doing a few more examples of differentiating using the chain rule, I'll use both notations.